Assalamualaikum and welcome back. We're still on partial derivatives, first partial derivative. Now let's continue with where instead of you have a function with two independent variables. Now let's say you have a function with three independent variables. So if you differentiate a function with three independent variables, you will get three different partial derivatives. One is partial f partial x. We also have partial f partial y, and the other one would be partial f partial z. And to calculate, to find the first partial derivative of f with three independent variables is similar to partial derivative with two independent variables. So if you want to find partial f partial x, what you do is you differentiate with respect to x, and you hold the other variables, in this case would be y and z, as constants. Okay, and if you differentiate partial f partial y, you hold the other variables, which are x and z, as constant. And similarly, partial f partial z, partial f partial z, you differentiate with respect to z, you hold the other variables, which are x and y, as constant. Okay, let's look at example. I'm just going to give you one example. Let's say this is from tutorial 1, this example. Okay, let's say you're given w is, as you can see here, we have a function with three independent variables, which are x, y, and z. So here we have x sine of x, y, z. Okay, and we are asked to find, so here you can see that the notation that that we use here is partial notation instead of subscript notation. So what it means here is you can also use subscript notation or partial notation. So in this case, if you want to find partial w partial x, we hold y and z as constant. So here you can see we have y and z here, and here we have x. Here we have x sine of x, y, z. So this is product of two functions. First is polynomial x, and the other one is sine x, y, z. So to differentiate a function with product of two functions, we have to use the product rule. So if you recall, for product rule from engineering math 1 or from high school, if you have a function multiply with another function, so let's call this u and v. Okay, so what you do is you differentiate the first function, you keep the second function, and then plus you keep the first function and then multiply with the derivative of the second function. So in our case, this would be our u and this would be our v. Okay, some of you can do this very quickly. Okay, so partial w partial z. All right, so we differentiate the first function first. So in this case, we want to differentiate u. So u in this case is x. Differentiate x with respect to x, we get a 1. Not very professional there, but I'm going to write it down anyway. And then we just copy the second function, which is sine x, y, z, plus, and now we're going to copy the first function. So the first function is x, and then we're going to differentiate the second function. So the second function is sine x, y, z. So here we have a function within a function, so we have to use the chain rule. So differentiate sine, we get cos, but it's going to be cos of everything, and then you have to multiply with the derivative of the inside function. The inside function is x, y, z, but remember we differentiate this with respect to x. So here we're gonna differentiate x, y, z with respect to x. So here, if you differentiate x, y, z with respect to x, we consider y, z as constant. So y, z times the derivative of x, which is 1. Okay, so simplify this, we get sine x, y, z plus x course, I'm doing this very slowly. Some of you can do this very quickly. So that will give us yz, okay, because we consider y and z as constant. Differentiate x, we get a 1 times y times z, that will be yz. Okay, simplify this even further. We have sine xyz plus xyz cos xyz. Okay, now we can get the value of this at this point here. Okay, so partial w partial x at 0.1 1/2 pi. Okay, replace x with 1, so we have 1 times pi over 2, a half and then pi, so that will give us pi over 2. And here we have xyz, that will give us pi over 2. And here we have cos pi over 2. But we know cos pi over 2 is 0, sine pi over 2 is 1, so we have 1 plus 0. Here we have a 1. Okay, so that is where you have function with 3 independent variables. So same rule apply. If you differentiate with respect to x, you consider the other variables as constant. Okay, and yep, that's it for this video. Thank you.